Okay, so during the break, a couple of you guys brought up some good points. Whenever you have a research question, you want the research question to be clearly defined. And so, for example, prior to the break, we said, what percentage of Americans are obese? You would want a clear definition of who counts as obese and who counts as an American, right? Do you have to be a U.S. citizen to be an American? If you're living in the United States, are you an American? Who gets classified as an American? Who gets classified as obese? Guideline is maybe a lot of times medically, people are considered obese if their BMI is 30 or higher, and that's a very clear definition. We take your height, we take your weight, stick it into a formula, it spits out BMI, and if that number is 30 or higher, you are considered obese. That's just how it goes. But again, anytime you have a research question, you want everything relevant to be clearly defined. Okay, so now we're going to get into just introductory material from the textbook. Today's lecture will cover Chapter 1 and Chapter 2, Section 4 and 5. Okay, and I'll cover Sections 1 through 3 in Chapter 2 next week. Okay, so again, this week the material that I'm covering is very, very easy. So don't think that, I don't want you to get the false impression that this is how the entire course is going to be. Oh, I'm sorry, Chapter 2, Sections 3 through 5. I'll do Sections 1 and 2 next week. Okay, so Sections 3 to 5 in Chapter 2. And again, today's content or material, in my opinion, is very easy. Okay, it's just kind of a lot of defining of things. So we've defined a population and we've defined a sample. What is just quick check of our understanding? What is the population? Try not to look at your notes. Yeah, the population is everybody relevant to your research question. Okay, so in the question we said, what percentage of Americans are obese? The population would be all Americans. If we said, what percentage of women are obese, or let's say, what percentage of women in California are obese, what would the relevant population be? All women in California, right? So the population is everyone relevant to our research question. Okay. And a sample, what is a sample? Yeah, it's a selection from the population that we will study. Okay, ideally our sample represents the population, or our sample is representative of the population. No one has made any complaints, so I'm assuming everybody can see the screen clearly and read and follow along. And I apologize that my handwriting is not any neater than it is. This is just how I write, so. Okay, so we're going to just start defining other terminology. So today's week is mostly terminology, very little in the way of calculations, but that will be coming, don't worry, if you're excited about that. We have, imagine a data set, okay? Okay. A data set can be thought of as our sample, but kind of represented in grids and columns, or rows and columns. Okay. So for example, if we, so sorry, it's one of those times when it gets crazy loud again. I should have my mic checked out. So for example, we could ask, can you hear me? No, maybe, okay. We can just gather data on people in California or something like that. And we can ask for your name, and we could ask, you know, male or female, your height and weight. And let's just say this, okay? So maybe our population is all Californians. All California residents. Okay, and our sample, we will just randomly select some California residents. Now this process of random selection I didn't really describe, other than saying you're going to take a list of everyone and select from it randomly. In actuality, that's actually very difficult to do, but we're just going to pretend that we were able to do that, okay? And so maybe we have John Baker, male, 5'9", 160 pounds. Okay? And then we have Susan Reynolds. Is that a real person? I don't know. Probably. Okay. Female, 5'2", 110 pounds. Okay. Et cetera, et cetera, et cetera. I don't feel like listing out all the people in our sample. Okay. But you can imagine gathering data like this, right? So here I've only listed off 2 people, but you know, maybe we've selected 150 people, okay, in our sample. And so my table would have how many rows? 150 rows, right? If I've got 150 people in my sample, I would end up with 150 rows total. Okay, 1 for each person. 1 for each individual in my sample. Okay, and so we can think of our data set as 1 row for every single person in our sample, and then we'll have different columns for the different pieces of information that we collected about each person. Okay, so how many variables do I have? Okay, yeah, we have 4 variables. We have the name, the sex, the height, and the weight. Sometimes people might say the name is an identifier and it might not count as a variable, but we'll just say each column is a variable. So we'll say we have 4 columns, we have 4 variables. 4 variables. Each column is a variable. Okay, so whenever we talk about a data set or a distribution of data, try to imagine what your data table would look like, okay? And so that means if you got 150 people in your sample, your data table would have 150 rows. If we had selected 600 people in our sample, we would have 600 rows, okay? And maybe you're only collecting 1 variable. Then you would only have 1 column. If you're collecting multiple variables, you have as many columns as you have variables. Is that cool, everyone? Okay, so we have different types of variables, okay? And in our class, we're just going to broadly define two categories. And maybe in another statistics class, they would further divide these into more and get, we're just going to say there are numeric variables and categorical variables, okay? For example, we can just say there's cars and there's trucks. Somebody else might say, oh, well, the cars get split up into coupes and sedans and whatever, and the trucks get split up into these things. We're just going to choose two very broad categories, okay? And so we have numeric variables and we have categorical variables. Okay? Numeric variables tell us how much. Or how many. Categorical variables and numeric variables will have a number, okay? Categorical variables tell us what kind. What kind or what type. May or may not have a number. So in our table, sex would be considered numeric or categorical? Categorical, right? That's very easy. All right, what about height? Height is numeric. And weight is numeric, okay? Numeric is sometimes also called quantitative, from the word quantity. And categorical is sometimes called qualitative, from the word quality. Okay, some quality of some trait or quality of a thing. But we usually say numeric and categorical, but you might see the words quantitative and qualitative. Okay, so we've got this and that. Okay, so let's just check our understanding. If I asked someone, if we said, do you have children? The answer to that would be numeric or categorical. Do you have children? Categorical, because the answer is yes or no, right? So that's a category. If I said, how many children do you have? That would be numeric. The answer could be 0, 1, 2, 3, 15, okay? So there you have a numeric variable. Okay. What if we asked, your sex, your height, your weight? Let's say we asked, what is the area code that you live in? What is your area code? So this guy says, I live in 310, and this person says, I live in 212, or whatever, okay? Area code is numeric or categorical? Okay. Does it tell us how much or how many, or does it tell us what kind or what type? Okay, it doesn't tell us how much or how many. Okay, it tells you a type, okay, or a kind. Just its area code would be categorical. Okay, it tells you what, I guess, the category or type area code thing that your phone is listed in. Okay, it doesn't answer how much, because anything where you have a how much or how many, you can make comparisons. If somebody says I have 0 children and someone says I have 2 children, you can say this person has 2 more children than this person. You can make a comparison. But if someone says I have area code 310 and someone else says area code 212, you cannot say this person has 98 more area code than this person. Okay, that statement does not make sense. It's not a how much or how many. Okay, so even though there's a number, area codes are represented with numbers, it's not a numeric variable. Okay. Questions on that? Yelp rating. What is that? So you get 4.5 stars on Yelp or 5 stars on Yelp. Numeric or categorical? Yeah. So I would argue that it's numeric. Okay, it's numeric because you can say this restaurant has, you know, their Yelp rating is 1.5 stars more than this other restaurant. Okay, and because you can make that kind of comparison, I would say it's numeric. Okay. And so we have that. Okay. So you've got numeric and categorical variables. This is an important concept. If at the end of the class, if you can't tell the difference between a numeric and categorical variable, you don't deserve to pass. Okay. This is, you've got to be able to say this is numeric and this is categorical. Okay. And it makes a big difference because the way you approach a problem will depend heavily on whether the variable is numeric or categorical. And so not only will I say you don't deserve to pass if you can't tell the difference between a numeric and categorical variable, but chances are you won't pass because you'll do all of your problems wrong if you get numeric and categorical variables mixed up. Okay. The book goes into a little bit more data. They talk about things such as stacked data and unstacked data. It's not super critical in my opinion, and so I'll leave it to you to look in the reading to get that. The book also makes the point that context is key, and this is true in statistics. It's also true in every part of life. Okay, context is important, and again, I'll leave it to you to do your reading and make sure you understand the concept of context is important, but it's simple enough to say, you know, if somebody comes up to you and says, I'm pregnant, okay, the context of that situation will have a very big impact on your response, right? If this I don't want to say too much or anything, but you know, you can imagine a situation where somebody's saying, I'm pregnant, and you're very excited for them, and you can imagine a situation where someone says, I'm pregnant, and that may not be as welcome news. So context is important, so that applies in real life. It also applies to data, okay? Looking at data from today, knowing the year that the data was collected, will play an important factor in, you know, your understanding of it. Okay, so 1950s America looks very different from 2015 America. So data that you look there, like if we just looked at something as simple as women in the workforce, okay, it's going to look different. You know, occupations that people had in 1950 America versus 2015 America, you know, different things will play a different role. Okay, so context is important. The book just spends some time talking about that. Okay, I'm just going to say do your reading. All right, I don't feel like I need to write a whole bunch of stuff on the screen for you to write down in your own notes when you can just read the book. And it provides kind of, says everything that I would want to say anyway, right? So do your reading there, okay? Okay, was there a question? No, okay. All right, organizing data, okay? So sometimes we have our data set, the one with the rows and the columns, that we might call our raw data table. Okay, so the raw data table is the table where every subject in your sample has its own row. Okay? So if you work in school administration and you have a listing of every single student enrolled at the school, that could serve as a raw data table. And maybe for each student you have whether they are male or female, what grade they're in, all of this other information. Now, sometimes we don't want to have to deal with the raw data table just because there's so many rows. And so we would like to summarize it, okay? And so we can create summary tables. Okay? And so one summary table is known as a frequency table. Okay? So the summary tables allow us, these are tables that summarize our data so we do not have to look at every single row in the raw data table. All the rows in the raw table. Okay? But just like anything else in life, a summary tries to capture what's important, but that also means you lose detail, right? You read Cliff Notes, so you don't have to read the full book. It tries to capture what's important in the story, but you're going to lose some of the detail. Okay? You watch a movie, instead of reading the novel, it tries to summarize or capture the essence of the story, but you're going to lose some detail. You won't know that Ron Weasley wanted to save the whatever, okay, house elves. So we have summary tables. We have frequency tables. This is one form of a summary table. Okay, a frequency table is a summary table. And what this does is it takes something like a categorical variable. So for example, we could say sex, and we will say male and female, and we put the frequency here. Okay? And so what it does is it goes through our raw data table and it counts how many males there are, how many females there are. How many people did I supposedly gather information on in our raw data table? In the previous page I said supposedly there would be 150 people. So the total will be what? 150, okay? So let's say we went through and we counted 72 males. How many females would then be in our, what did I count? 78, good. Okay, right? Because everything needs to add up to 150. And so here is a frequency table that summarizes everything that was in our raw data table.
I'm not sure that I find that definition descriptive of what it's doing. Could you restate it in a different way, please?
The frequency table or the summary table?
The frequency table.
So frequency, well, so I was just giving an example here, okay? So the frequency table for categorical variables, okay? Because you can have a frequency table for numeric variables, but okay, so, but this is for a categorical variable. Okay? Lists the categories that appear in the data. Okay, so for a categorical variable, so here we're just looking at the categorical variable sex. Okay, so lists the categories that appear in the data. So in our table, we only saw males and females present. I suppose, we could have another category there. And then for each category, it lists the frequency of that category. Or in other words, the count of how many times it appears. Okay. So there we have that. Is that okay? We also have another summary table, and this is called a two-way table. Okay. So a two-way table, okay, is another summary table, and this takes two categorical variables. So maybe we are looking at sex. So we have males and we have females. Okay. But then we're also going to look at another categorical variable. So maybe we looked at left-handed or right-handed, okay? Okay. So there's a total of 150 people, right? So that goes in the grand total over there. How many males total did we have? 72, which means we had 78 females, okay? And, okay, so of the 72 males, we would have to go through the data, but we could pretend we counted and we said, oh, out of the 72 males, 10 are left-handed. So how many right-handed males do we have? 62, okay? And let's say 11 females are left-handed. So how many right-handed females do we have? 67. How many left-handed people do we have total? 21. And how many right-handed people do we have total? 129. Okay? And so this is a two-way table. Okay? So basically, on each axis of the table is a categorical variable. Again, we're looking at two categorical variables at the same, two categorical variables. So we look on each axis of the table is a categorical variable. In each cell is the count or frequency of people with those traits. Okay, the margins have the totals. Good? Okay, so I'm going to, we're going to continue working with this table right here. Did I switch the slide too quickly? Yes, I need to go back. Oops. All right, so I'll leave this up for a moment. Okay, so you don't have to recopy it. This is probably already in your notes, but I ran out of space, so I copied it. Okay, so we could ask questions such as, well, we should be able to answer these questions, okay? So, what % of people surveyed are left-handed? Okay, and I'm going to ask what % of people surveyed are male. Okay, so go ahead and use your calculators to answer this question. Today, if you don't have a calculator, you can use your cell phone, but make sure by next week you have a calculator to use. Okay, so you should be able to answer both of these questions relatively quickly. So I'll give you about 1 minute. So what percentage of people surveyed are left-handed? What percentage of people surveyed are male? Okay, so let's answer this. Percentage of people surveyed who are left-handed. How many people did I survey total? 150, okay? So 150 will go in my denominator, okay? So what % of people surveyed? There's 150 there, so that's going to put 150 in the denominator. How many are left-handed? 21. So I'm going to do 21 divided by 150, and I get 14%. Okay. And what percentage of people surveyed are male? So how many people did I survey total? 150. How many are male? 72. We're going to do 72 divided by 150, and what do we get? 48%. That's easy, right? Everybody got that? So that's just basic, I don't know, proportions. Okay, so now I'm going to write a few questions that are all similar sounding, but they give very different answers. Okay, and we got to be able to tell the difference between each of these. What percentage of people surveyed are male and left-handed? What percentage of males are also left-handed? What percentage of left-handed people are males? Okay, so go ahead and take a minute to solve those. the answers for all three are different. Okay, so even though they sound similar, they are different questions and they all have different answers. Okay, so what are the answers here? What percentage of people surveyed are male and left-handed? How many people did we survey total? 150. And how many people are male and left-handed? So I'm going to do 10 divided by 150, and I get 0.066666. So I'd write 0.0667, okay? So that would become 6.67%. I guess I should have turned these into percentages. 14%.
Is there a normal amount of decimal places that we're supposed to just
my rule of thumb is at least 4.
Okay.
But and you know, make sure you're rounding correctly, right? So if I cut off at 4, it says 6, but because it's 5 or higher, you go to the next. My rule of thumb is 4, but you know, if it's a smaller number, you probably need to keep even more. If you got more leading zeros, you're going to need to keep more decimals. Okay, what percentage of males are also left-handed? Okay, so to answer this one, how many males total do we have? 72. So 72 goes into my denominator, right? Because we're asking of the males, how many are there? 72. And how many are left-handed? 10. So we're going to do 10 divided by 72. And I get what? 13.13888. So %. Do that. Okay, and what percentage of left-handed people are males? What do we have there? 10 over 21, right? Are there any questions on this? Oh, 4762. I'm going to write 47.62%. Is that good with everybody? Okay, good. This is easy peasy. Okay, it's about as hard as today's stuff is going to get. Let's talk a little bit more about gathering data here. Okay, so you're going to have, you know, on next week's quiz, you'll have questions dealing with a two-way table, asking questions like this. Okay, so there's just want to make sure before I move on, and if there's any questions, now's the time to ask. I just want to make sure that the distinction between questions 3, 4, and 5 are all clear to everyone. Yes.
Did you quantify the point, the decimal point by the percentage?
Yes, to get the percentage, all I'm doing is I'm moving the decimal point over 2 places to the right.
Oh.
Okay, which is the equivalent of multiplying by 100. Yes, question?
So is that what a quiz would look like? You would give us a table and you'd ask questions?
Yeah, this week's quiz is very easy, okay? Or I mean next week's quiz, in my opinion, very easy. And I've got a few questions. You got a sample quiz online. It'll give you a good idea of what kind of questions. Of course, the questions won't be exactly the same, but it'll give you in my opinion, a fair idea of what to expect, okay? So next week's quiz, everyone's probably going to get 100%, okay? Maybe 90% if you mess something up. But next week's quiz is easy, all right? I think. You might struggle, and if you struggle, that's not a bad thing. It's an opportunity to learn. Okay, so when we talk about gathering data, okay? So again, the idea is we have a population, right? The population is this big thing that we cannot observe directly. And so we're taking a little piece out that we're going to study, and this is our sample. Okay? How we select this is our process of gathering data. Okay? So this is selecting our sample or obtaining data. Okay? This is how we select our data. So there's a few ways, okay? So first off, we're going to talk about just anecdotes. Okay? Anecdotes, these are not real data, okay? Anecdotes are things like, oh, you know, my aunt was once sick with this disease and she drank this herbal juice and she got better. Okay? So you should try this juice out because you are also sick. That's an anecdote. Okay? Now, the herbal juice may actually be beneficial. It may not be. Okay? We don't know. One person's story does not tell us exactly what's happening, okay? Your aunt could have gotten better because of the juice she drank. She could have gotten better for a million other reasons, and it was just a coincidence that she happened to drink the juice. And because of our faulty reasoning as humans, well, maybe we attribute her getting better to that juice she drank, okay? But that may or may not be the case, okay? When you only look at one person's story, or even just 5 people's stories, okay? You might be able to find 5 people with similar stories. That is still not enough to say this is then, you know, these 5 people, what happened to these 5 people or what happened to this one person will then happen to all million people or all, you know, everybody in the population, okay? So anecdotes don't really count as real data, okay? We have to do either an observational study or a controlled experiment with a decent number of people to then be able to make conclusions about the population, okay? So just because something, you know, you had some success at some point in the past for one or a few people, that doesn't necessarily mean it will translate to the population, okay? So I'll just write it very quickly. You know, what happened with one person or a select few people okay, will not necessarily happen with the population. Okay, so we have observational studies. Okay, with observational studies, we are looking at a sample of people. Okay, we study a sample of people. And again, our sample should be representative of the population. So maybe you are interested in the effects of drug on childhood cancer, okay? Your population would then be all children with cancer, okay? And your sample will be a selection of children with cancer, and you're hoping that that selection of children will be representative of all children with cancer, okay? That's kind of a sad subject, but it happens and it's important research, okay? With observational studies, we observe the subjects, and other than taking measurements or making recordings and other than observing, we don't interfere with the subjects, okay? Other than taking measurements and making observations, we do not interfere with the subjects, okay? So we don't assign, we don't say you got to do this or you got to do that, okay? And with an observational study, we can establish association. We can establish associations between what we call factors, or between variables. We'll just say that. We can establish associations between variables, okay? However, we cannot attribute cause and effect. Okay? So we can say these two things tend to happen together, but we cannot say this thing is causing the other thing. Okay? So from observational studies, we might be able to say people who have vitamin D deficiency tend to have more of this disease, okay? Whatever that disease is, okay? But from an observational study, we cannot then say vitamin D deficiency is the reason this disease is more prevalent, okay? There could be something else, what we call a lurking variable, behind it that actually causes both the disease and the vitamin D deficiency. We don't know, okay? There could be something else going on that is causing what we happen to see. But we might say there seems to be a link between vitamin D deficiency and this disease. And if we catch you with low vitamin D deficiency, maybe we should screen you for this disease, okay? Not necessarily that this causes the other, and it doesn't mean that, okay, well, you have low vitamin D, so we're going to give you more of vitamin D, and that makes the disease go away, okay? We can't do that, okay? So example, okay, we might be able to establish that patients with low vitamin D are at a higher risk of some disease. Okay? But we do not say low vitamin D causes the disease. Yes, question?
Is it somewhat comparable to I guess like symptoms of disease?
Not necessarily, but ooh. Sometimes the gain just shoots up like crazy. So what am I saying? Okay, so here's a silly example. Okay, if we looked at households across the nation, okay, we looked at children's reading scores in school, and we looked at the number of appliances in the house. Appliance being dishwasher, microwave, range, TV, all of this stuff. What you will see is you will see households with lots of appliances will have children that have higher reading scores, and households that have fewer appliances will have lower reading scores. Okay, this is a fact. Does that mean the solution to help better educate our children is to provide more appliances? No, that's silly, right? Okay, and what we would see is that, you know, there's kind of an income disparity. Households with lots of appliances generally have high income, and also higher reading scores, and the opposite, lower income, lower reading scores. Does that also mean the solution is to provide more money and income is the solution? Okay? No, it's kind of an accepted fact that for whatever reason, you know, income correlates or is associated with, you know, school performance, but it doesn't explain why. Okay? It's not that income suddenly makes somebody able to read more. Okay? There's all sorts of other things going on, but from an observational study, you can make that link. Yes, question?
2 questions.
Yes.
For an observational study, does it have to take place in the subject's natural environment, or can it take place in a lab, or does that not matter at all?
It can take place in a lab. It can take place in a controlled environment. That's also fine. But in general, with an observational study, you don't want to interfere with the subjects other than taking the measurements. So maybe they're going to live their life and they have to come to the lab or the place to get their measurements. But outside of that, or maybe you're doing some kind of study and it requires them to be in a lab setting for an extended period of time, but in general you're allowing the subjects to kind of make their own choices and things like that. Okay? Yes, another question.
And then the other thing is, what exactly counts as interference? Because in one of them, the example you gave earlier, it would be about like medications. Like,
oh, you know, I misspoke. That I should have saved that medication example for the experiment. Okay? So contrast the observational study to a controlled experiment. Okay? In a controlled experiment, we try to control as many aspects of variation as possible. Okay, and we assign treatments randomly to our subjects. Okay, so in the ideal case, and a lot of times we can't have the ideal case just because life is complicated and there might be ethical considerations, but in the ideal case, we have two groups of subjects. both subjects both groups have the exact same conditions except one group has treatment 1 and the other treatment 2. Other group has treatment 2. And usually one of those treatments is the control, considered the control. Okay? And then, so at the end of the experiment, okay, any differences between the groups can be attributed to the fact that they had different treatments, okay? Because everything else about the groups were the same, right? So both groups had the exact same conditions, and the only difference between this group and this group was this group had the treatment and this group had the control. And so if there's any difference at the end of the experiment, we can say it was because this group had treatment and this group had control. And everything else, because everything else was the same.
That's like placebo effect trials.
Yeah, so, okay, so I'll get to that in a second here. Okay, so at the end of the experiment, any difference we observe between the groups can be attributed to the fact that they had different treatments. Okay, and it will not come down to the fact, you know, because in a poorly designed experiment, maybe you had group 1 and you had group 2. In group 1 you gave the treatment, in group 2 you gave the control or the placebo or whatever it might be, and you wanted to record what happened. But maybe group 1 was all women and group 2 was all men, okay? This would be a bad experiment, because if at the end of the experiment you see a difference between what happened to group 1 and what happened to group 2, you wouldn't know if that difference is because one group was women and one group was men, or if it was because this group got the treatment and the other group was the control. Okay, that would be a bad experiment, because the two groups in the initial set conditions are different. Okay, so ideally you would have, you know, a mixed group, group 1, and a mixed group, group 2, and you would have everything else also the same. They're, you know, under the same this and under the same that. And the only difference is that this gets the treatment, this gets the control, and that's why they're different. Yes?
So one of the groups is called the control and the other group, what's that one called?
So often you have the control group and you have the treatment group, okay? So you'll have, you know, control group, and you'll have treatment group. And we assign the treatments, okay? So we the researcher, we assign who gets which treatment. Okay? Okay, and there's something known as the placebo effect, where if you say, here, we want to try out this drug to see if it has an effect on, let's say, people are experiencing anxiety or something like that, okay? And we want to try out this drug and say, we're going to see if this drug treats your anxiety, okay? And so we're going to give people this drug, experimental drug. Just the fact that they're taking something might automatically start calming them and reducing anxiety, and then the other group we say, oh, you're in the control group, so you don't get any pills, that might already put them under a psychological effect. So in order for people to not know which group they're in, we have what we call the placebo. And so we give both groups pills, okay? This group gets a placebo pill, which should scientifically should have no effect on their brain chemistry or anything like on their body, okay? It's just a little pill that does nothing, okay? It's like eating a cracker. It shouldn't do anything. And then the other group gets the actual drug. And then we can make a comparison between the group that gets the placebo and the group that gets the real drug. Yes?
Isn't that also where we do like the blind studies and stuff?
Yeah, so we do blind and we do double blind because, so the blinding, a blind study prevents people from knowing which group they're in. They shouldn't know whether in the control group or treatment group, and that's often done with placebos. And a double blind is in it, so sometimes you have something that's easily measured, right? Did somebody lose weight? It's easy. You put them on the scale. If that number is lower, they lost weight, okay? Other things are a little bit more difficult to evaluate. Did somebody get better at playing basketball, okay? You would need somebody watching, preferably someone experienced, like a basketball scout or a referee or somebody with experience, and they have to make a subjective evaluation, okay? And so in a double-blind experiment, you don't want the person who are making evaluations also. You don't want them to know whether they're in the treatment or the control group, okay? So I'll write that down, okay? So blinding. So this, the subjects don't know which group they are in. Okay, and placebo is one way to blind. Okay, and in double blind, people making evaluations also don't know which treatment is used. But so with an experiment, you can make cause and effect conclusions. So this is the key here. With a well-designed experiment, you can establish cause and effect. Okay? The trouble is, experiments may not be practically or ethically possible. If we wanted to study the effects of marijuana on a developing brain, we cannot conduct an ethical experiment, okay? Because that would require us to take developing brains, so children, and then exposing them to marijuana against their will, because we are assigning treatments, right? We say, thank you for volunteering. Now you are going to smoke marijuana, and we're going to see what happens to your brain, okay? We can't, that's not ethically possible, and so those types of experiments aren't available to us.
Also plan to, like, not just, I mean, not with just, like, children, but with, like, adults or something. Wasn't that also plan to, like, cultural things, like, because I know, like, in, I think it was, like, San Vincent or, like, Jamaica, marijuana is viewed as something that creates, like, makes you more active in the workforce and helps you focus and stuff, while in, like, the U.S. it's viewed as the opposite.
Okay, so perhaps you could do a study on the effects of marijuana on the brain in a place like Jamaica where it is acceptable and you'll have a bunch of volunteers, okay? That might be permissible, okay?
But also, wouldn't it be like placebo? Because like in there it's viewed as one, while here it's viewed another.
Yeah, and so again, you have to look at the subjects you selected, right? And so in this case, in order to conduct a ethical experiment, it required you to go to another country, okay? And so your subjects are from Jamaica or whatever, okay? And therefore, the conclusions you make can only be generalized to the population that your sample represents. So in our case, our sample would be Jamaican people, or people from Jamaica, and therefore our conclusions can only be generalized to the population that it represents, and so our conclusion can only be generalized to the people of Jamaica. It cannot be generalized to the entire nation, or I mean entire world, or things like that. So anyway, so that's something to consider. But maybe you're going to say, well, this is just something where overall we're looking at just a chemical thing in the brain or whatever. Okay, that's what we're going for. Okay, is this okay? All right. So very quickly, we just have a few minutes left. We can, going back to categorical data, okay? So this is now sections 2, 3, 2, 4 in the book, okay? 2.3 and 2.4. We're going to display categorical data with bar charts, okay? Display categorical data. And our primary tool is bar charts, okay? Another tool is pie charts, but these are less preferred, okay? And all we're doing is, with a bar chart, we take our summary table, so our frequency table, right? So let's say we have male and female. We had a total of 150 and we had 72 and 78. With a bar chart, it's very easy. You just write male, and you put female over here, and you just mark off 10, 20, 30, 40, 50, 60, 70, 80, okay? And so for the males, you have a bar that goes up to 72, and for females, you have a bar that goes up to 78. And there you go, okay? And if you want to put the number 72 and 78, that's also fine. With a bar chart, the order of the bars doesn't matter. Okay, so if you want to put females over here and males over here, that's fine. Just like in the summary table, the order of the rows actually doesn't matter. If we want to put females in the first row and males in the second row, that's also fine, okay? I probably put males in the first row just because of established patriarchal society and etc. whatever. But you know, it doesn't matter. Whatever row you want to select as going first and whatever column you want to put first or bar, that's fine, okay? Pie charts, you're gonna have a circle, and then you've got to say like, oh, 72, you know, you got to do this nonsense, okay? And you know, you got to turn it into a percentage and then to a fraction, okay? Oh, one other thing. So we have our frequency table. We can also have another column called the relative frequency. And it's very simple. All you do is you just turn it into a fraction, right? So you do 72 divided by 150, and we said that's 48%. So the relative frequency is going to be 0.48. And female, you do 78 divided by 150, and you get 0.52. Okay? So the relative frequency will always be add up to 1 or 100%. and all you do is you're just turning the counts into percentages or proportions. Is that cool? Okay. And so you can imagine doing the same kind of thing, but with, you know, maybe you have more categories, right? So maybe we looked at hair color. And so we have black hair. I don't know, maybe we'll have dark brown, light brown, blonde, red, other. Okay? And then you have numbers here, okay? The count or frequency. Okay, and then so here you just write down the different colors: black hair, dark brown, light brown, etc., etc., etc. Blonde, ... and then you would draw the bars. Something like that, okay? I'm just making this up. And of course, you need to have a scale on the other axis, okay? So 10, 20, 30, 40, 50 to establish how many people you've got. Okay? Yes?
How did you get the 0.48 on the regular frequency?
Oh, to get 0.48, I did 72 divided by 150. Okay? Turn it into a percentage. Is that okay? So the last question, or the last topic, is describing variation in a categorical variable. Okay? So I'm going to show you two graphs. Okay? And let's say we ask people, are you Republican, Democrat, or other? Okay? And let's say we went to two different locations. Okay? And we ask the same thing: Republican, Democrat, or other. Okay? And so in one location, this is what our results showed. Okay? This is how many Republicans we had, how many Democrats we had, how many other. Okay, so 10, 20, 30, 40, or something like that. Okay? So this will be location 2. This is the results of our survey. Okay, and then the other place we asked, are you Republican, Democrat, or other? And this is what we get. Okay. Okay. This is location 1. So which location has more variation in party affiliation? Okay. So we asked, are you Republican, Democrat, or other, or independent, whatever. Okay. Which location has more variation in party affiliation?
Location 1.
Okay, and the answer is location 2. Location 2 has much more variation than location 1. Okay? Because if you go to location 1, pretty much almost every person you meet will be what? Republican, okay? So in location 1, this is like everybody thinks kind of the same, okay? I'm not saying that, but everybody, at least politically, the vast majority of people think in a similar way, okay? So you don't have a whole lot of variation here, okay? In location 2, you've got a great diversity here. You've got some people Republican, some people Democrat, some people other, okay? So you've got a variety, a range of things, okay? Over here, almost everybody is Republican. You very few Democrats, very few other parties, so you're going to have less variation there, okay? You can think of this also like, think of, you know, race in Los Angeles versus racial diversity in China, okay? In China, pretty much everybody, well, not everybody, but a lot of China looks very similar to itself, okay? You don't have a whole lot of racial diversity. And so if you looked at a bar chart of racial or ethnicity in China, you're gonna have one giant spike for people that look Chinese, and you're gonna have very small things and other things, okay? And we're gonna say that's not very diverse, okay? You go to Los Angeles, you've got people of all different races. You have white people, you have black people, you have Latinos and Asians and all sorts of things, and so you're gonna see kind of this more leveled thing, leveling out here, okay? So the rule here is if one category seems to dominate the others, there is less variation. Okay? So in a time when, you know, everybody looks the same or thinks the same, you've got less variation, and that might make for easy policy making, but it could also make the people in the smaller categories feel oppressed or things like that, you know, whatever. But that's what we have going on. Okay, so that concludes today's lecture. You've got homework assigned on the website. Just make sure everybody has the class website, classes.smileschen.com. Practice quiz is also up there. And we'll see you guys next week.